Units and dimensions. Units and dimensions. What is a physical quantity? What is a physical quantity? A physical quantity is a measurable concept. It is a measurable concept like distance, speed, mass, time, etc. What is distance? That which we walk. Distance is that which we walk. We can understand it but cannot define it. We can explain or describe the concept with its properties. So, a physical quantity can be understood, we can explain its properties, but it is difficult to define it. Different systems. We have CGS system, MKS system and system international. We measure the physical quantities, in different systems. The first one is CGS system. The earlier systems are CGS and FPS. Then from CGS we derived MKS system, and finally today the universally accepted system is SI system, system international. This is universally accepted system in scientific community. Physical quantities and their units. A physical quantity is a measurable concept, and today we adopt SI system in scientific community. In this system there are 7 fundamental physical quantities and 2 supplementary physical quantities. The 7 fundamental physical quantities are length, mass, time, electric current, luminous intensity, thermodynamic temperature, quantity of matter. These 7 are taken as fundamental physical quantities: length, mass, time, current, luminous intensity, thermodynamic temperature and quantity of matter. Along with these 7, we take 2 supplementary physical quantities: plane angle and solid angle. Plane angle and solid angle. The units that are adopted in SI system are meter for length, kilogram for mass, second for time, ampere for current, candela for luminous intensity, Kelvin for temperature, mole for quantity of matter, radian for angle and steradian for solid angle. The units are meter, kilogram, second, ampere, candela, Kelvin, mole, radian and steradian. Meter is for length, kilogram is for mass, second is for time, ampere is for current, candela is for luminous intensity, Kelvin is for temperature and mole is for quantity of matter, radian for angle and steradian for solid angle. Like this we take the units. To measure the physical quantities. We define units. First let us understand how meter is defined. It is defined as 1,650,763.73 times the wavelength of radiation emitted by krypton atom when electron transition takes place from 2p10 to 5d5. Like this we define meter in terms of wavelength of radiation emitted by krypton atom. It is equal to 1,650,763.73 times the wavelength of radiation emitted by krypton atom when transition takes place from 2p10 to 5d5 state. Like this we define meter. Unit of mass, it is kilogram. A kilogram is defined as the mass of a prototype made up of platinum and iridium, in which 90% is platinum and 10% is iridium. 1 kg is equal to 5.0185 into 10 to the power of 25 into atomic weight of carbon C12. It is a prototype which is placed in Sevres near Paris. The unit of time is second. Second is defined in terms of number of periods of oscillation of a cesium atom. There are two superfine states in which the atom continuously oscillates, and the time taken for one oscillation between these two levels is a period, and 1 second is the duration of 9,192,631,770 times the period of this radiation, the period of oscillation of this atom between these two states. So, second is defined in terms of the period of oscillation of the cesium atom between two superfine states, and it is equal to 9,192,631,770 times the period of this radiation. Ampere, ampere, it is the unit of current. It is the unit of current. It is defined like this: if there are two straight conductors, parallel conductors placed in vacuum at a distance of 1 meter, then if the current passes through both the wires in the same direction, then there will be a force of attraction. If this force of attraction is 2 into 10 to the power of 9 meters over 1 meter length of each wire, when the same current is passing through the wires, then the current in each wire is taken as 1 ampere. The current in each wire is defined as 1 ampere. So, it is that current which, when flowing through two straight parallel conductors placed in vacuum at a distance of 1 meter, if the currents can produce a force of 2 into 10 to the power of minus 7 newtons over unit length of each wire, such a current is known as 1 ampere. Kelvin, it is the unit of temperature. It is defined basing on the triple point of water. It is a state at which water exists in all the three forms: solid, liquid and vapor states. Its temperature is taken as 0 degrees Kelvin, or its temperature is taken as 0.01 degrees centigrade, and 1 by 273.16 times of this temperature is taken as 1 degree Kelvin. Triple point is nothing but a set of pressure and temperature. For water, it is 4.6 millimeters of mercury and 0.01 degrees centigrade, and we can understand 0 degrees Kelvin as the temperature of minus 273.15 degrees centigrade, Candela is the unit of luminous intensity. To understand candela, first we have to imagine freezing platinum, solidifying platinum. It freezes at 101.325 pascals of pressure. At this pressure, while freezing, it emits radiation. This radiation, measured over 6 lakh part of 1 square meter over an area, 6 lakh part of 1 square meter is taken as 1 candela. To understand this area, imagine that the square is of 1 square meter area, and divide it into 6 lakh square units, equal areas. 6 lakh square units of equal areas. The radiation emitted from each square is taken as 1 candela. Like this, we define candela. Mole. It is the unit of quantity of matter. It is the matter contained in Avogadro number of particles. 1 mole of a substance means it is the matter contained in Avogadro number of particles. For example, if you take C12 atoms, carbon 12 atoms whose mass is 12 into 10 to the power of minus 3 kgs, Avogadro number of these atoms, the mass contained, the matter contained in Avogadro number of these atoms is taken as 1 mole of substance, 1 mole of substance. Radian, radian, this is the angle subtended by two lines. Suppose if you take a circle of radius r, a circle of radius r, on this circle imagine an arc of radius r, imagine an arc of radius r. The angle subtended by this arc of radius r at the center is taken as 1 radian, 1 radian. So, in a circle, in a semicircle, we have 180 degrees which is equal to pi radians. In a semicircle, 180 degrees is equal to pi radians. Hence, 1 radian becomes equal to 57.3 degrees approximately, 57.3 degrees approximately. So, radian is the angle subtended by an arc whose length is equal to the radius of the circle at the center of the circle. The angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. Like this we define radian. Sterradian, sterradian, it is the unit of solid angle, it is the unit of solid angle. For example, take a sphere of radius 1 meter, take a sphere of radius 1 meter and consider a circle of area 1 square meter, a circle of area 1 square meter. The solid angle subtended by this circle at the center of the sphere, the solid angle subtended by this circle at the center of the sphere is taken as 1 sterradian, 1 sterradian, 4 pi sterradians. At the center of the sphere it will be 4 pi sterradians.